What's up, everybody? Welcome to the first lesson of geometry. Hopefully you printed off the outline of the notes. If not, you can just follow along and kind of copy the information down. Remember, you can use your notes on quizzes, so definitely a good idea to take notes for sure. Alright, so for section 1.1, we're learning some of the basic terms that we're going to use the entire year. Points, lines, and planes. Now you probably have a rough idea of what those are, but we're going to get a little bit technical as far as geometrically to talk about how do we use points, how do we use lines and planes, how do we name them, how do we recognize them. Now back in Algebra 1, you plotted points on a coordinate plane. You then connected those 2 points to create a line. So remember back in Algebra 1 when you were doing good old y equals mx plus b, you were graphing lines, you were using points to figure out where the line would go, what direction it would go, and you were doing all of that in a plane. So if we think back to what a graph might look like, just like that, and I'm just going to throw 2 random points in there, all right, and then when I connect them, that's what creates the line. So you do need at least 2 points to create a line. I think we all know that. And the points are what give that line direction. So now let's talk about how do we label these in diagrams and how do we identify points, lines, and planes. So the first one is the point. Now a point is a location, right? It's a certain specific spot on a graph or in a space. Now we usually represent points with a dot, and then we usually name that dot with a capital letter. So if you ever see a dot and a capital letter next to it, that is the name of the point. Okay, so we name points by using capital letters. That's very important, all right? So points are always named using capital letters. And it can be any letter they want, so we'll usually I'll pick random points throughout the alphabet, or the book will, or the worksheets will. Now a line, as I already said, is made up of at least 2 points. So the reason why we need 2 is because it needs a direction to travel, right? Now here's the thing with with a line. You can name lines in a couple different ways. So if you look at that drawing I just put up there, notice that I have A and B, which have dots underneath them, but then I have a lowercase n. We use lowercase letters in this instance to name lines if we didn't per se have points on the line. So if I wanted to name this line, I could do it in 3 different ways. I could call it line AB. Now notice, if I'm naming a line, I use this special notation above it. So that's the letters A and B representing the points, but then that's a dash with arrows on both sides. So a dash with arrow on both sides, so something just like this, dash with arrows on both sides. That's showing that that is the name of a line. And the reason why it has arrows on both sides is because lines travel forever in opposite directions. There is no end point. I could also name this line BA. So the order that we list the points does not matter. It eventually will matter for something called array, but for a line, the order does not matter. And then I could also name this line N. So if I'm just using the lowercase letter, you usually want to write the word line and then N. I don't want to just have N, we want to say line N. So if I'm naming a line, I can either use 2 points that are on the line, or if it has a lowercase letter next to it, I can use that letter and say line N or line X or M, all right? Our next term we're coming to is a plane. Now, think of plane as a flat surface or a piece of paper. So a plane is a flat surface made up of many points that extend infinitely. So a plane, just like a line, travels forever and has no endpoint. Now for us, within our diagrams, the planes are going to have endpoints, but theoretically, a plane does not stop at it. There is no boundary to it. Now, the reason why we say paper is because paper stays flat. I'm not talking about rolled up piece of paper. I'm talking a nice flat piece of paper. Okay, so something like this. So notice I have 3 points, A, B, and C, because there are dots next to those letters. But then I also have the letter K. And this is a similar idea as the lowercase n for a line. So when I name this plane, there's a couple different options here as well. I can first say plane ABC, or plane BCA, or plane ACB. Now notice, all 3 of those options all contain 3 points. And that's the key if you're trying to name a plane by using points. You need at least 3, and it does not matter what order they're in. So I could have also said plane CBA as well. That would also work. So it doesn't really matter what order they're in. Usually you put them alphabetically, but technically you don't have to. Now the other catch here is that K. Notice that K has no dot next to it, so that's not naming a point. That capital K is actually the name of the plane. So similar to how you can name line N based on the lowercase n, it's like the name of the line. This K is the name of the plane. All right. So to name a plane, you need at least 3 points, or you can just say if this is present. Now the thing is, this is not always going to be present. Like that K with no point. Same thing with this N. That's not also always going to be present. The point is, if it is there, that's another way we can name these figures. Now, all of those terms we just looked at, point, line, and plane, those are called undefined terms. The reason why they're called undefined terms is because there's not really a definition to go with them. We describe them, but they don't have a set definition. We also use visual examples to show what they are. So again, they're undefined terms because there's not really a set definition. You describe them or use a diagram to relate what they are. So these 3 terms, super important as we progress through the year. So now let's look at 2 more terms that are really important. The first is collinear. Collinear are points that are on the same line. Okay, so collinear means, so when I say name 2 collinear points, I'm asking you to find 2 points that are on the same line. All right? And the term coplanar, that's points that are in the same plane. Collinear, on the same line. Coplanar, in the same plane. So points A, B, and C would be considered coplanar because they are in the same plane. And then A and B over there on the line, those would be collinear because they're on the same line. All right? So let's put this a little bit to the test. Here is a diagram. So as you look at this diagram, I want you to think, how many planes do you see? How many lines do you see? So you really have to kind of think of this as a 3-dimensional diagram. Now the reason that bottom part of that line is dashed is because that's like if you were seeing through the plane. Alright, so that's you seeing through the plane. So I want you to look at that diagram and then think, I want you to pause the video, and can you name 2 lines, a plane, 3 collinear points, and 4 coplanar points? So again, pause the video and see if you can figure that out. Alright, so hopefully you paused it, looked at it a little bit. Now, I see 2 lines. I see this line running vertically, and then I see this line running horizontally. I see 1 plane that's drawn, which would be this blue surface. Alright, now if I want to name them, there's lots of ways that we can name these lines. So there's more than one correct answer. So if I want to name this vertical line right here, I can name it RT. Remember the correct notation. I could name it TR. I could also name it XR because I'm using the point X. I could also name it line M, because that M right there, notice there's no point associated with it, and it is a lowercase, so that's also referring to that line. Okay? Now the other line, the one running here, right? That could be named in so many different ways as well. Notice there are 4 points on that line, so you can pick any 2 of those 4 points to name this line. I could say VW, I could say AR, or notice it has this little lowercase n, I could also name it line N. Any of those work. Now if I want to name the plane, and here's the thing that I maybe forgot to say last time, if I'm naming a plane and I'm naming it using points, all 3 points cannot be collinear, right? So hopefully we notice that point X is not in this plane. So I couldn't use point X to name the plane. Also notice that all of these points here are collinear. I can use 2 of those points, but I can't use all 3. So that means if I want to name this plane using points, I have to use B, because B is not on the same line as these other ones here. So I could say plane VWB. V and W are collinear, that's fine. As long as all 3 are not collinear, then you're okay. I could also name this plane P. Notice this P right here, there's no dot associated with it, so that P is not naming a point, it's naming the plane. All right? Finally, let's name 3 collinear points. Any of these 3 would work, or T, R, and X would work. Coplanar points, 1, 2, 3, 4, 5. Any 4 of those points would work. All right? Last but not least, intersection of geometric figures. So the intersection occurs when figures have 1 or more points in common. And there's 3 main types of intersections that we're going to be looking at this year. And they're each represented in this diagram. So the first one is the intersection of 2 lines. Now eventually we're going to talk about lines, segments, rays, stuff like that. But they're all the same idea in that they're 2 straight lines intersecting. The second middle diagram is the intersection of a line and a plane. And the third diagram is the intersection of 2 planes. So what you want to think about is, what do they have in common, or where are they touching? Are they touching in multiple places, or are they touching in one place? So when 2 lines intersect, they are only touching at that one point. And when they intersect, they create a point. So we could put any letter we want on that. When a plane and a line intersect, think of a pencil pushing through a piece of paper. It's making a hole. What's another way of describing a hole? That would be a dot. A dot is associated with a point. So that is 1 point. So whenever lines intersect, or a line and a plane intersect, they're still only touching once, creating 1 point. The trickier part is when 2 planes intersect, right? So I want you to think of a book and all the pages it has, right? You can make it so that one page doesn't touch another page, but eventually they all meet at the binding of the book, right? And that right here means that they all have that common distance, the width of the book in common. So when 2 planes intersect, they create a line. And that is kind of very important to notice, because like they're touching each other the entire time on that intersection line point. All right. Last but not least, just some definitions to throw out. So eventually we will have lots of terms that have definitions, and we use points, lines, and planes to describe them. All right, and we will eventually also have things called theorems and postulates. And then the last thing to understand kind of what we're doing, geometry is a lot about the study of space and how objects interact with each other in that space. So space is a boundless three-dimensional set of points which can contain lines and planes. So notice I'm using those undefined terms to make a definition of space. All right. So guys, for your homework tonight, you're going to have 1.1 worksheet. A lot of it's just taking the knowledge we just learned today and naming and labeling figures. So good luck. Please let me know if you have any questions.